specification. So some of the models work good with this kind of thing, or maybe some models are good for different kind of tasks. So there is another issue is that if I just show you with this Chat GPT API and all, so you won't be having that API because it's not free of cost. You have to buy that. You have to get some access token out of it. Then only you can work. So we will use some preliminary basic large language models, which are the open source models. Alongside that, what I will need is that you must open ChatGPT, where you can just type out some of the things that we will discuss today. So ChatGPT gives you this kind of interface where you can just search anything. Probably all of you are familiar with this. So the thing is that I want today is I must give you this file, the file that is present to you. You must use that. And let's start. So you will be having this file, which is the Advanced Prompt Engineering IPython notebook file. And you can open it with Google Colab, or even you can open it with your local system if it supports. And I think since we are using small models, we are not going to use bigger models, at least for this notebook. So you can probably use it anywhere. So I will give you some time so that you can just download this and make your environment setup. Just try to run this few cells. So this first 2-3 cells you should like run, then we can discuss the rest. So I have opened a notebook here. So this is not the Google Colab notebook. It is a notebook which is being run locally in our system. I have done this because in Google Colab, you have to download these models every time because it's not saved anywhere. So it will take much more time. So let's get started. So what we will do, I will just give you like brief idea. So generally, what we are trying to achieve with prompt engineering is that we are not, as you can see here, we are not going to prompt and pray that some outcome comes magically, right? So in reality, if you prompt and you are waiting for some results and you have not properly formatted the prompt or given the prompt properly with respect to the model, then probably you will end up with something that you don't expect. So that's the problem. But if you know the systematic way how different model behaves, in that case, probably you will end up with a few number of steps that you can follow. Of course, you might not get a perfect result with the very first time. But instead, if you can give a better prompt, probably once like in few steps, you will be getting that answer that you are looking for. So that is what we are trying to do. We are trying to achieve that how the language model behaves and how there are different parameters that we can utilize to actually solve different kind of problems. Now with ChatGPT, you don't have many of these resources. Basically, ChatGPT, like this interface, just gives you enough thing for like a general public to actually ask something and get something out of it. So most of you are aware that people are using ChatGPT for code generation, for making any kind of text, for paraphrasing and all of this stuff. So it is quite good at it and you don't have to do anything specific about it. But the thing is that when you are doing something technically, probably you will require either an open source LLM because maybe you don't have that much amount of money to pay the GPT models, or maybe you are trying to use offline models for some security purpose. So there could be any number of reasons, but we can think of it at that this ChatGPT interface is not that much flexible. So only the thing that you can do here is prompting. So you don't know which model you are using right now. If you are not paying the premium, you don't know that what will be the outcome beforehand. But it is generally default parameters and default things that we'll discuss. So here you can see that when we are starting to do prompt engineering, we are essentially trying to learn or understand how a large language model works. But that's a very difficult topic. Probably you have gone through the topic of transformers. In that, probably you know that different models work differently. So there are sequence to sequence models and there are decoder only models and there are encoder-decoder models. So sequence-to-sequence models are basically encoder-decoder models. Bigger models like ChatGPT, these are decoder-only models, whereas there are models like FLAN T5, which are essentially sequence-to-sequence or encoder-decoder models. But generally, we see any big language model to be a decoder-only model, and they work pretty well for the tasks that they are used for, basically the generation of text. So understanding this basic idea will give you a lot of head start for the prompt engineering. So let's start for the first code section. So I think probably you have like been able to set up this interface. I've given you enough time for that. So here we will import some of the things that Hugging Face library provides. So before installation of this, you have to install all the libraries. And I hope that you know that which libraries are required. For example, transformers, PyTorch. So these are very frequently used for large language models. I expect that you must use a kernel, specific kernel for your work, that is basically a virtual environment, so that your code will be within that range, so that you should not mess with any other code that you are working on. And in this case, you will see that there is an access token, because there will be two models that we'll be working on. One is the FLAN T5XL, which is an open source model and does not require any kind of access token. And there will be another model, which is essentially this Meta Llama 3 8 billion parameter instruction tuned model, which actually requires you to have an access token. So you can get this access token from Hugging Face library. So if you just go to Hugging Face, so you just type the name of this model. So Meta Llama 3, if you do that, let's see which model we'll be working on. So this is the model, as you can see. So you will see that here it's mentioned that you need to agree to share your contact information to access this model. So basically you have to request access from your own Hugging Face account. You have to log into this Hugging Face account. And once you have that, you will be requesting the access to this model. And once Meta give you access to this, you will be able to get this token key that I'm using here. And probably will be good with that. And now this access key is not shared with you. Either you can create your own access key, or what you can do is you can just go to ChatGPT and do the same thing, because for the first section where we are going to use this Meta Llama, I will just show you the differences, and you can just see how much difference you are getting in this ChatGPT interface also. So if you are asking the same questions, we might get different answers for that. So let's just start with the first prompt. So let's run it. So whoever is running this code, please try to run it in your local system. Just you have to give this access token. That's mandatory. So now we will start with this prompt template and loading this pipeline and generated response. So before that, I will just try to start this model, because it might take time for your case, because these are 4 checkpoint shards which will be downloaded if you are using Google Colab, and then those will be loaded, right? So it will take some time. So just run it first. Now let's go to the first prompt. So let's understand this prompt structure. So this will be the basis of the entire class today. So in the prompt, it is essentially, you can see a list of dictionaries. So here there is a dictionary, which is separated by another item of dictionary, right? So the first thing is that there are 2 keys here. One is the role, another is this content. So the role, we will discuss what is it. It is essentially, we'll just type system or user or something else based on the model that you are using. So the model, whenever it's trained, it is already given that, yeah, you have to use these kind of roles. The model is fine-tuned on these kind of roles. So here, for example, the role is system, and this is the content that we are using. So for the role system, the content is you are a smart question solver. So let's just see one thing. Another is for this role user, you will see that the content is do goldfish grow. So what essentially I'm doing here is that I'm telling the model that you are a smart question solver. So it will act as a question solver. So let's just understand what does this mean. This means that there is this model, which is a large language model, and which is fine-tuned with so many huge big data, right? So it is trained on big data. Generally big text data from big sources. So once you have this LLM, you can understand that the idea is that if you ask some query, if you give it some query or prompt that we can say, so it's basically the input to this model, it will be able to generate some output. It will be able to generate some output. Now this output, how it will behave will depend on this training data. Now this training data, since it's big, the model in general condition, in the base condition, we call it as a base model. If you go to any like website, you will see either it's called a base model or a vanilla model, which means that the model is just the basic trained model and nothing else. So once this is done, what you will find that this model is quite generic. So it can like answer you very generically. But if you, for example, type something that create a table for me that will contain these rows and these columns and you fill it up with this, probably it will not be able to do it. And the reason behind is that this big data is generally a text data, which is good for training the next and next point generation, or we can say that the next token generation, but it's not good at creating some structural informations. And we are like focused on structural information mostly if we go to ChatGPT or anywhere else. In that case, there is something known as fine tune comes in. So you will be probably hearing this term fine tuning. So fine tune or instruction tune. So these two terms you will be coming around if you are using LLMs. So instruction tuning does mean that you will instruct the model to do specific tasks. And for that, you have to fine tune the model with the instructions. So for example, you give it some examples of these tables and show that, yeah, this is the table that I wanted. So if this is the question or prompt, then this is the table that needs to be generated. You show it some examples during the training. And once it's done, you will see that the instruction tune model is able to now actually able to generate this like table formatted, right? So one thing here you have to understand is that when we are doing this instruction tuning, we try to tell the model a system prompt. A system prompt. So the system prompts actually moves you to the location of the model where it is instruction tuned particularly for that system prompt. So if you tell that you are a creative table creator, that means the model will now understand that, yes, I have to create some tables, build some tables, which will have some rows, some columns, and some cells. In that case, it will be much easier for the model to give you the exact output. So this is just an flavor of how instruction tuning works in large language models, as you can understand. So what we are essentially doing here in the system prompt is that we are giving it a direction. So you are smart question solver does mean that you are giving an instruction to the model that now you are a smart question solver. So if it is instruction tuned for question answering or question solving, it will redirect its like weights or attention to that part of the model, right? So then after that, you will give the user prompt. This is the actual prompt that the model takes from you. So it is the user prompt, as you can understand. So this is the prompt you give to ChatGPT. So do goldfish grow? This is the question that I'm asking to the model. So let's just run it. And what you will do is you will take this your smart question solver and you will paste it here in ChatGPT. Again, you will just copy this do goldfish grow, which is the question, and you will just paste it just after in the second line, or maybe in the same line also it works. So the idea here is that you can see in ChatGPT, you are not able to give an instruction tuning prompt or a system prompt here because you are only given this user prompt interface. ChatGPT decides within itself what will be the system prompt. But since we are giving this information in the user prompt that you are a smart question solver, probably it will be able to redirect its attention to that particular part. So let's just give it a go and see how our model actually does the same. So that you can see that the model is loaded here. Let me just show you the pipeline. So you will see that the pipeline is a very simple and easy to use interface provided by Hugging Face, where the pipeline has entire thing built in for you. You don't have to do tokenization separately. You don't have to take the input separately. You don't have to take the output. So you don't have to do most of the thing. It will do it for yourself. So this pipeline actually takes in the task that you are working on. The task here is the text generation task. You will pass the model name. So the model name is essentially a Hugging Face model name. And this is the torch data type. So we are using torch.bfloat16. So this actually reduces the torch parameter size. This is not the model parameter size, but the calculation that is being performed internally, that will be reduced. So this torch D type will actually makes your model much faster, or it will take less amount of memory. And you have to understand that this is not quantization. Quantization is another thing where you actually reduce the model parameters precision. Here we are just reducing the precision for the calculation, internal calculation. This is device map. So this device map is also a very interesting and important parameter. So this device map parameter actually tells that in which location the model will be loaded. And the location will be either a CPU or a GPU. So if your system has a GPU, which is CUDA enabled, where the CUDA environment is set up properly, and this device map is set to auto, it will try to load everything to GPU, because as you can understand, the GPU is able to parallelly perform these calculations in the large language model, which makes it much faster. So the system that I am using right now is a CPU only like system. So here there is no GPU. It will directly like shift it to GPU. So the device map will now point to a CPU. Now this access token, you can pass it as a token parameter. It will be required for some of the models, as I told you. So this Meta Llama free 8B instruct model. Now, as you can see here, it will be much interesting to understand that what is this 3.8B. So 3 is the version of the model. So Meta Llama 3. So there is Meta Llama 1, Meta Llama 2, and Meta Llama 3. There is 3.1, 3.2. So there are some more versions. And now you can see this is 8B, which does mean that it is an 8 billion parameter model, and it has been instruction tuned. So that's why it's written that it's instruct, right? So else it could be something like base or vanilla. In that case, it's not instruction tuned. So this is an instruction tuned model. So it has been tuned for separate system prompts, different system prompts. So once we load this model into this pipeline object, you will be able to use this pipeline to actually just give the prompt. Now, as we discussed, that this is our prompt, which is a list of dictionaries that contains the system prompt and the user prompt. You can directly pass the user prompt also. That is not a problem. But if you give a system prompt, it's better. That we'll also discuss. So we will start with this response. So response equals to pipeline, and the pipeline takes, there are many parameters that we'll see, but right now you can see that simply you can just pass this prompt and the max new tokens. So what is this max new tokens? Max new tokens actually tells the model that you have a limit of generating like only 100 tokens and not more than that. And you have to understand that tokens does not equal to number of words. The tokens generated by the model does not mean that it is generating 100 words. So some words may have multiple tokens associated. So this is the thing that we want. So the output will be within this response. So the output will be generated within this response, and this is how we are going to parse this response. I'll just print this response and show you what we are getting. So let's go to this where we have this question given to this ChatGPT, and probably you have also given this to your ChatGPT interface. And you'll see that, yes, goldfish do glow. So this is the output that it is giving. So once it gives the goldfish do grow, it is then saying some things about goldfish. So it's giving you some reasoning behind why it told that the answer is yes. So it's quite intuitive and interesting. Yeah, so let's just print this once. So I'm just printing this response. So you will see here that it prints firstly all the prompt that is given, because it is a generative model. It takes the prompt and then it generates the next word or next token one by one. So it's like a continuation of the entire prompt that you have written. So you see that your entire prompt is here first. Then after your prompt is there, then there is this role which is assistant. Now you see there is another role. Firstly, we were like understanding that there is a role like system, there is another role like user, which is the prompt that you are giving. Then there is this role which is assistant, which is essentially the model replying to you. So the content for this assistant is this: goldfish do grow, but their growth rate and size can vary, so it's giving you some output. Now to extract this output, you just have to use some basic skills of Python. You just to see that this is within a list, so you will take the list value, so that's why it's a 0. Then we are going to give the key number, which is the generated underscore text. So you can see that this is the key that we are talking about, and then -1, which is taking the last cell of this last dictionary of this, which is essentially the role assistant. And for that, we are just going to take this content key. So for this content, you see we are getting this. So if you just print this, you will end up with this output, which the model actually gives you. So yeah, right now you see that the answer is quite similar to what ChatGPT gives. Now the model that ChatGPT is using is probably a trillion parameter model, whereas the model that we are using, as you can see, is a 8 billion parameter model. So it's a very, very small model compared to ChatGPT, but yet still it is able to provide a good amount of output, as you can expect. So you generally don't have to use a GPT-based model, even if you have a system that can run smaller parameters like 8 billion parameter model. So it depends on your prompt and your requirement that which model you should be using. So you don't have to waste much money if you can run these models locally. Now working with these hyperparameters. So now most of the people who are working with these models, even if someone is using models from Hugging Face, they actually suffer or don't understand that what these parameters do. And these are nothing but the LLM hyperparameters that you can tune, right? You can do the same thing for ChatGPT or GPT APIs if you are using the API version, but you don't get this kind of facility with this interface. As you can understand, you can just give the user prompt here. So let's just understand. So we will define only 3 different parameters which are mostly required. If you can utilize these parameters properly, then probably you won't need anything else. So the first parameter that we'll be talking about is do sample. So do sample is a parameter or hyperparameter to the model that you can give, and you can see that it is either true or false. So if it is true, it will try to generate something creative. That is, even if it doesn't have any information about it, it will try to understand what's happening or what is the data that is being trained on, and it will try to use that to give you that output. So it will be much more creative. If you say do sample equals to false, it will try to be predictable and factual. So what does it mean? It means that whatever the training data it has, it will give much more attention to that training data, right? So it will not try to deviate much from what it has learned from the training. So you can see that there is a clear boundary by using this do sample. But these LLM models are quite unpredictable many times, that we will also discuss. But this is the general thing. And that's why you have been given another parameter. And the second parameter that we'll talk about is known as the temperature. So as you can see, the temperature parameter is like having different values. For example, 0.1 to 0.3, 0.7 to 0.9. So it's divided based on the type of output that you require. So if you require very deterministic output, probably you will take these values very, very small. So you don't want the model to actually be having multiple variations for each of these lodges that we will discuss later. So what do you essentially want if you're giving the output 0.1 or 0.3 is that I want exact same kind of output. It should be very, very deterministic. Every time I run the model, it should give the same output. Then you have to use this lower temperature values. As we increase these temperature values, you can see that it will be much more balanced. And then one is the default parameter in some of the models. So when you are using this ChatGPT interface, probably in the backend, they are using the value of this temperature as 1. Then there is the parameter values, which is from 1.2 to 2.0, which gives you random and more diverse kind of output. So if you want output that will be very, very diverse, random, so you run the model, you will get different output every time, then it's useful. So you have to understand when you should be using 1.2 or something more than that, is maybe you are generating some kind of diverse variation of a query. You ask the model that give me like 10 different versions of the query. There you will need much more temperature. So you have to understand that there is a trade-off. Now, if you just keep on increasing it and just move towards 2.0 value of temperature, you will see that it will give you outputs which are not correct, which are factually incorrect. It will give you any random stuff. So you have to understand that you have to tune this parameter if you are working for a specific engineering task. Now there is another parameter. This is also very important, and I have seen many people not using this parameter in their work, and this is a very important parameter. So I think everyone should use it. So it's something known as a repetition penalty. So this parameter actually gives you or your model a general sense of feedback, that what kind of output you want, right? So for example, if it's 1, it gives no penalty, which is the default behavior. So if you don't use this parameter, it will be sticking to 1, and it will allow repetitions, right? It will allow repetitions. So for example, it will repeat the same information. So why this actually happens is that in transformer models, there is something known as attention. So if some tokens get more attention, the probability of their output will be higher. So for example, a term which is yes has a very high attention. In the output, it will see many, many times that it has been provided yes as a generative output. And we don't want that. We want something new to be generated. We want something proper to be generated. And we can control that using this parameter. So if you keep its value more than 1, you can increase it and see that which particular value works. So if it is, yeah. So within 2.0, so if you, for example, keep it 1.1, it will try to reduce these repetitions, right? So this is very important parameter. If you reduce it, it will be repetitive and it can use the same output many times. So what is happening inside is that it is trying to either penalty the attention or cover the attention, or it is actually giving more precision to the attention. So generally, this is what is happening internally. So this is what we want. We want these 3 parameters to control our model. Again, I'm saying that you don't have this option if you're using the ChatGPT interface. But if you're using this any API, mostly all the API will be having these parameters. Now you see, I'm using the exact same prompt from the previous one, but now I'm just giving in the pipeline. So you can see the previously just in the pipeline, we were using this prompt and this maximum tokens. Instead of that, now we will use few more parameters. We can see the parameters, we discuss the parameters. So one of the parameter now I'm giving is minimum length. So I'm giving that the minimum length will be 100. So this is 100 words. And tokens is a different thing. Token is the token that it will generate. Temperature is 0.5. So I have decreased the temperature. So the default is 1. Now the temperature is decreased. And repetition penalty, I have kept it as 1.2. So it's much more restrictive in repetition. It will try to less repeat. And this is max new tokens. This parameter we already discussed. And you can see in the second line that what we are doing is basically we are getting the output for the response. And we have done, so this is the exact same code as the previous one. So you just have to run it. Since it's running on CPU, it will take some time. Okay, so let it give some time and we'll see what happens. Now in the second phase, you will see that there is this prompt, and we will face this prompt and we'll give the same prompt to this large language model also. Okay, so the output is here. Yes, goldfish can grow. So you see how it is different from the previous answer. So in the previous answer, it has given that goldfish do grow, but their growth rate and size can vary depending on several factors and so on. Here you will see that yes, goldfish can grow. However, their growth and rate depends on several factors, such as, and it has given me some points now. Now you will see that on the same prompt, we can get different outputs. And the only thing that we changed here is that we have given it some parameters, right? So we have given some parameters, and understanding that how your response or output is controlled by these parameters is very much dependent on the model also. So right now, if I just change the model from Llama to Flan or some other model, you will see that even the same prompt and same parameter will give me some different kind of output. So this output parameters should be maintained for each and every model. Even if it is the same model, you have to understand that there are different versions of the model. So for example, the 8 billion parameter model, the 13 billion parameter model, the 70 billion parameter model, all of them needs to be tuned separately. So these parameters will be different for all the models that you will be using. So you have to take in mind, and you will see that based on the output that you want, you fix that and see whether the output is proper or not most of the time. So it is possible that you might not get the exact same output every time. It is possible that you will get different output, but in general, if you are, for example, trying 100 times, at least 90 times or 92 times, the output should be consistent. That is what we actually want to achieve from this. So this is the next prompt that we'll be using. You see the prompt is right now here in this line, which I have selected. So the prompt is, the system prompt is that you are smart question solver, again is the same one. And now I have given the role and the content. And what is the content? Content is a variable string, multi-line string. So it is how multi-line strings are written. So in this multi-line string, the passage is goldfish don't grow. So I'm just writing here, goldfish don't grow in cramped bowls with poor water quality, and their growth is often stunted, leading to much smaller sizes. So this is one paragraph that I've written. Use the above passage to answer the question. And then now I am giving the same question. So you can see I have written that goldfish don't grow, and then given it some reasons that in this particular conditions it doesn't grow, right? So let's just run this. I will just run this here. It will take some time, and I'll copy the same thing to ChatGPT, and you can do that. So we will see what are the different output we are getting here. So you can see that you are a smart question solver. Then the passage is given here. After that, use the above passage to answer the question, and the question is, do goldfish grow? So yes, yes. Okay, so what is the answer? Yeah. So yes, goldfish do grow, but according to the passage, they don't grow properly in cramped bowls. So it was able to handle it much properly as anyone would expect. So giving this as an input, you actually try to redirect the model. As you can see, if you give some context to the model, it will try to blend itself based on that. And we will see a very interesting thing here, right? So it's very, very interesting that we'll see here. So let's see what is the output. Yeah. So you can see that even 8 billion parameter model is actually adapted to this context. According to the passage, yes, goldfish do grow, but only under certain conditions. And then the passage states that goldfish can grow if they have a suitable environment, such as a spacious bowl. So it as you can see, written in a different aspect. So if it is a small bowl, they won't grow. And that's why the model said that the passage says that a spacious bowl actually helps or allows the goldfish to grow. So it's entirely correct. And you can see that how The context actually help the model to redirect to the thing that you want. So for example, I have this kind of information or context. I can provide this to the models. That will help the model to redirect, right? So now we will move on to this second thing, which is the principles of effective prompts. So there are some things that we need to understand for effective prompt engineering. One is the specificity, where you must be clear about the output that you want, as much clear as you can go. Now, just for your information, if you're using a very small model, for example, FLAN T5XL, which is a very small model, 3 billion parameter model, there, if you change the prompt even a bit, the output changes significantly. So in that case, the prompt must be very precise and correct, and it should be very small as well. But for a larger model, the prompt can have multiple variations. Just your intent should be proper. So if you're designing the same information need, in that case, you must not be able to give the same question or query to the model or prompt to the model for a larger model. But for a smaller model, this matters most, because in smaller models, it won't be able to capture the information need with this diverse amount of prompts. So clarity should be there in the desired output. Second thing is, you should be able to provide relevant information, context setting, as we have done here. So we have given it some context and additional context. For example, I've given some passage here that actually helps the model to drive its output. Then the thing, third thing is that instruction structure. You can give it some instruction, much more specialized instruction. For example, stepwise or some explicit instruction that we'll see what would be this kind of instruction. So these are some of the techniques that we'll be using. First is the role prompting. I have discussed generally what is role prompting till now. This is the second thing is this few shot prompting. Then there is multi-step prompt, and then there is chain of thought prompt. So the multi-step prompt we have already done in the previous course, if you remember, if some of you were in the course. There is a link in my GitHub repository if you want to go to that. We are not going to deal with multi-step prompts. It's just essentially the prompt that we were dealing with right now, and will be under a loop where the context will be saved, because this list of prompt will keep on increasing, and we'll just feed on this prompt to the model and it will give you the output. So we are just skipping that part. So role prompting we have already done, but we'll see what are the different role promptings we can do, simple examples. Then we will do some few shot prompt and the chain of thought prompting. Then we'll move on to some other things. So this is a basic prompt, right? So I have picked a very difficult problem for LLMs and even for some humans also who are not familiar with maths right now. Maybe it will take very large time for someone to solve. So you can just go to this page and see what is the actual question. So it's a big question. I am not repeating the question here. So it's generally a mathematical question which requires some minimal formulations. And if you are able to do it, then it's fine. So in the prompt, you'll see in the last, I have written a statement which says that you should output only the answer and nothing else. So I'm doing some kind of restrictions. I want the model to just output the solution to the problem and nothing else. So this kind of restrictions gives the model or you a flexibility of capturing the output from the model. But there are some benefit and downsides to it that also we can discuss, that we should discuss. So let me just copy the same prompt. We will paste it similar to this ChatGPT. We'll paste the same prompt to ChatGPT and see what we get. So is the entire same pipeline? I'm not discussing it. I'm just running it. And you'll see that I have used max new tokens to 200 for most of this. The reason behind it is that we cannot use more tokens. It will take much more time here. So yeah. So here we will just run the same and see what we get. So the output here is that you can see it is giving 200, right? Let's see what is the output given in from our model. Okay, it's giving me 210. Now you can see that the same problem given to two different models where the answer should be same. So generally 210 and 200 are not same, right? So for this kind of mathematical question, the answer will be an exact definitive value. So if those are deviating, that means at least one of the models did not work well. Now you may expect that since ChatGPT is a very bigger model, probably it's right. Maybe it's true. Let's see with some variations in the prompt what we get. Now in the second one, I have given a system prompt. So you can see that here the system prompt is entirely missing. So it's not having a system prompt. So the system prompt is you are a mathematician. And I have given the same prompt, but the last part is not here. So let me just add this exact same prompt. It should be an exact same prompt. Output only the answer and nothing else. So we can see that if giving a system prompt actually helps. So right now we had no system prompt earlier. Now I have just added a system prompt that says that you are a mathematician who evaluates output before giving it to user. Who evaluates the generated output. So what I told is that you are a mathematician who evaluates the generated output before giving it to a user. So basically, I'm trying to tell the model that you should be confirmed before giving the output. Let's see if it makes any changes. So the prompt is the same prompt that we used earlier. But you see, earlier it took a very less amount of time, but now it took more time. I can just show you once again. So if I run this previous model, so the output is 210. And if I'm running it now, it essentially took very less time. So it again outputs 210 because the parameters are same because we are not changing any parameters here. But here you see the output again for the same model actually changes if I just change the system prompt. It is now showing 250. Let me run it again and see what kind of output we get. So you can see how much unpredictable the answers could be. Now it says it's 270. So it's quite random, right? Okay, I'm not going to chat GPT for this. We can try out some things here. Now I just remove this output only the answer and nothing else. So this was to make my output more specific so that at the end of the output, I can just extract the output and use it for my purpose. But instead now I will just remove it. It will try to probably explain or maybe check what is the output that it is giving. Let's run it. And let's run the same thing to the chat GPT. So let's give the same thing to ChatGPT, and here let's give the system prompt also. Since ChatGPT doesn't take a system prompt, I'm giving it as an user prompt. It will help the model to redirect a bit, of course. So you are a mathematician who evaluates the same thing and then the prompt, the basic question, and I will just send it. So now you can see previously it just gave a simple output because I told that output only the answer and nothing else. This helps in getting us some fixed answers. Now you see here that it is now able to explain and do the steps, and now the answer changes to 175 kg of corn. So previously it's 200 kg when given by this model ChatGPT, and right now the answer changed. Let's see what is the answer from our model. I'll be happy to help you with that. Let's break it down step by step. So it has given some steps. So the cornfield yields 175 kg. Now you see, previously we got 210, 250, and so on, 270. And now after the calculation, it is able to do it. So this is what we are calling it as this chain of thought prompting. So we are asking the model to reason within itself that whatever the output you are getting, you match the output with the question again, you check for the solution by yourself, then give the output. And you see here, by just changing the single line where I wanted the output in a single line, and since these are generative models, it is just generating one token. And you can understand, just generating one token, you cannot have all this mathematics or these formulations being done in the backend, right? So only thing that it output, if I tell it that, it gives a generic random output. For the ChatGPT model also, it does the same. Now we will make it much more clearer. So I am just giving it that you are mathematician. Now I just change the system prompt a little bit. I will just give it. Now you can see some idea about consistency of models. And I will just copy this prompt. And I will run it. So only thing that changed here is that think step by step to solve. So this is one line. And this is a line that you generally use for chain of thought prompting. So if you just type this line, think step by step to solve, and then you give the actual prompt, user prompt, then it will try to incorporate chain of thought prompting if the model is fine-tuned for that. So let's just give it. So you are a mathematician, think step by step to solve, and we just give it. So you see that let's solve the problem step by step. It then again generates this query, and right now again 175 kg. So previously also it told that it is 175 kg, and that's fine. That is what we wanted. So even without giving, as you can see, for these models, even without giving that you should be doing this step by step, they can understand which questions can be used using chain of thoughts. So these models are being trained and fine-tuned so much properly that even if you don't tell explicitly to do it, it will be able to do it in most of the cases. But as you can see here, what we get. Okay, so let's start by solving this problem. Okay, so it has taken something. So now you see changing this prompt here actually makes the problem harder for a smaller model to solve. It tried to explain now, and it failed to explain. Now it tells that it is 1050 kg. So we knew that previously it was able to generate 175 kg as the answer when we didn't tell it to use step by step to solve. Now we instruction tuned the model to think step by step and solve the problem. And you see that it did the exact same thing, but it did wrong, right? And the thing here is that we can understand that some models are not very much good instruction tuned to follow the instruction of chain of thought prompting. So it's a very smaller problem. Probably they will solve it in the next iteration. In some of the cases, maybe some of the questions it will work, and some of the question it might not. So one thing that I wanted to show you here is that the output from the model is very, very undeterministic in most of the time. So even if you know that the exact output of can be calculated by this model, but you can see that by changing just the model parameters or some model variables in the prompt, actually you can actually disrupt the actual output. So giving more information, for example, this think step by step is not always good for a smaller model. That is what I was talking about. So for a smaller model, as simple as the problem could be or the prompt could be is better. So I think this till this part is quite clear. So I can give you some more prompts. So for example, now the system prompt is act as a customer support for agent for TCS, and then reply to the following user complaint in a friendly and professional manner. And the problem is that my account on TCS and portal is not shown. So for this, let's say what kind of response is generated. Uh, you can just copy the same and put it in this GPT to get the output. You'll see that for this kind of prompts, because these are generative prompts and the models are trained on quite similar kind of data. So the expectation is that they will generate almost similar kind of output. So this comes with some experience. So let's see what is the output that. Okay, so yeah. So you see here that it is creating some mail, right? So dear user, thank you for reaching out and so on and so forth. And then best regards, so your name here, and this TCS and customer support. And same thing you get it from here also. So subject, dear user, thank you for listening to us, and so on. So you can see that that asking this kind of questions will give you almost similar kind of output for both the models, even if it is a bigger model. So this is the kind of experience that you will get once you like work with this kind of models properly. So, okay, I'm not going through this, right? So this is another type of prompt. So this is a few shot prompting. So few shot prompting means, these large language models are trained with huge amount of data. And if you want to change something or give some new input to it, it will require you to fine tune the model, which actually requires huge amount of infrastructure in that aspect. So in that case, if you have, for example, some examples lying, not much of an examples, you can directly incorporate those examples in your prompt. That will be helpful for your model to actually learn it without even fine tuning the model. So this is very, very important. This is very, very important, and this is very much used in the current research industry, and you will see. And my particular research actually focuses on these kind of aspects where we use in context learning based kind of things. So I have a few research works that actually uses this in context learning. So you can understand that this kind of thing is very new and is very useful in many aspects or many fields, I would say. So the example is that you are a linguistic expert. So right now I'm directing the model that you are a linguistic expert. And then I'm saying that correct this grammar. Example one is she want no food, she no want food. So I'm just correcting it by this. Example two is he go to school, where the output should be did he go to school. The input here is they is late and the output that we want, right? So right now it is just a blank thing. So let's run it. So you can give the same thing to ChatGPT also, it will be able to do it. So you are a linguistic expert. So then we are just going to give correct the grammar. This is example one. This is example two. And this is the input and this is the output that we want. So the output it is giving is there late. So the corrected output of the sentence will be they are late. You can see that both the bigger and the smaller open source models actually give you the exact same kind of output. So yeah, you can use like few shot prompt technique that utilizes this few shot mechanism where you are not actually able to actually fine tune a model, and you don't actually require to fine tune a model even. And these are very helpful if you are doing some kind of domain specific task. In that case, you don't have the model trained on those kind of data. In that case, you can have your local data available with you. You can just give it as a context or ICL example in context learning example, and the model will be happy to give you the output regarding that. So now recognizing hallucinations and inaccuracies and the predictions. So as you can see, even with few examples we have done till now, is that the models are quite hallucinating. And right now there are different guardrails to do that. So one thing is that I'm just giving it this prompt, so answer the question, what is the population of Atlantis? So this is if someone knows what will be the answer, probably you may know. And let's see what the model does it for us. So let's give the same thing to ChatGPT. Yeah. So let's see what is the output from ChatGPT. So the ChatGPT is telling that Atlantis is a mythical city and it's described in ancient text and it doesn't have an actual population. And that's right, because many of us who know about Atlantis actually know that this is a valid answer, right? So let's see what this model tells. is the exact same thing. I'm afraid I have to disappoint you. According to myth and legend, Atlantis is a fictional place. So it says the exact same thing. So I'm not going to discuss that. Now let's move on to the second one, where we have this. So answer the question, what is population of Atlantis? If you are unsure, say I don't know, right? So I am telling, it's very specific that if you don't know about what is the population of Atlantis, you just say no. Just same prompt to ChatGPT, and you'll see here it gives I don't know. Okay, fine, that's good. And here you'll see it gives also I don't know. That's very reasonable. Now I will just change something, and this is what is interesting. You will see, and this is what makes different models different. You have to understand which model works, how you may have to experiment with it for your own domain, your own work in that case. So right now you see that the user prompt is within this ICL content, and the ICL content is this. So here, answer the question, what is Atlantis? The thing that we use. Answer, a newly identified island is named as Atlantis, which has population similar to India. Great. And then again, answer the question, what is the population of Atlantis? And there is this answer. This is the prompt that we are going to give. Let's just copy this and run it here, and let's just copy it here and see what kind of output we get. So the population of Atlantis is similar to India. So you see, I have given a context. So it's like a few shot prompt or a context you can understand. So this is actually a few shot prompt, and this is an example of one shot prompting. You can see that I have given one example, and the example question is, what is Atlantis? And the answer says a newly identified island is named as Atlantis, which has population similar to India. Very good. So what is population of Atlantis? It tells that the population of Atlantis is similar to that of India. Fine. Great. Let's see what this model tells. According to this previous answer, the population of Atlantis is similar to that of India. So even if the model knows that Atlantis is an like mythical place with no population information, it can be redirected with prompt or with few shot prompting. So the few shot examples that you are providing should be very accurate in that sense. Now you will see in the second one, we will do the exact same thing, just I will change a very few things. So answer the question, what is Atlantis? Now the answer is Atlantis is an island found in 1990, which has population similar to India. Now I have shifted it, so I've given a timeline that it's found in 1990, and these models are generally trained in last 1 or 2 years, right? So they have this information. They should be having this information. Let's see what kind of output this model gives versus what ChatGPT gives. The ChatGPT gives the exact same answer. The population of Atlantis is similar to that of India. Is thinking that which has the population of India. It is giving much more attention to this part and does not compare with the fact that Atlantis is a mythical island which it has learned already. So you can understand that giving wrong information or some information which is, because in the few short examples, you have to choose the examples very carefully. So it can drive some models crazy, like for ChatGPT. Let's see what kind of output. Yeah. So here you can see a smaller model is able to give a very good work, very good output. So I think there may be a problem here. According to initial answer, Atlantis is the island found in 1990, which is a population similar to India. However, this is not accurate. So you can see that a smaller model is able to give a better output than a larger model. So it all depends on the task that you are solving. It depends on the prompt that you're using. So it's entirely dependent on the prompt, the task, and the different parameters. So the limitations of context window and model choice. So here now we will shift to another model. So we'll shift to another model, and you can just clear your model because we are going to load a different model. This is the FLAN T5 Excel model. So just go to FLAN-T5 Excel model and see. So this is the language model page. You can go here. So it doesn't require any kind of access token and all. So right now we don't need the ChatGPT anymore. We have like completed that part. So this is the model, and you will get all the codes and everything here. Let's just go to here. So here I have loaded this tokenizer and the model separately. So right now I'm not using a pipeline. That's what I'm going to say. This is a function that cleans the LLM output, because sometimes the output contains the characters like separators, the line end tokens and all. So we don't want that. So this function you can use in your own work also in some aspects where you can just clean the output of the LLMs. Now I'm giving it a prompt, and the prompt you are very much familiar with. Do goldfish glow? So this is the prompt that we used earlier. So let's run this model and see what is the output we're getting. So it tells no, goldfish reach the maximum length of your natural lifespan, 3 to 4 inches. Okay, fine. It's giving this kind of output. Again, I'm running this. Goldfish can't grow beyond 2 inches in length. Okay, good. So you see how much difference output it is giving, right? And the reason is that the do sample is set to true. Now you see it says yes. The previous two answers were no, and the third time I run it, it says yes, a goldfish grows up to 1 centimeter in length. So you can understand that these models, there are some models, and this is a very smaller model, and this is a sequence to sequence model, which is not great at task generation or text generation, but rather it can generate small text that we will see. So I have just changed that. So previously I told that you can restrict the model by saying, if you are unsure, say that I don't know, right? You can use this kind of prompt to restrict the model to not give any hallucinated answers. But here you will see that it still gives the answer. Goldfish don't grow, but they can live up to 20 years, whatever. So it is not being restricted. Even if the model has less information about a particular topic, doesn't mean it will follow all the instructions that you provide. So this is a model that we are talking about, which is a 3 billion parameter model. And if you give the same prompt to a larger model, probably it will work. But I will show you the same model can work effectively if you are going to get some discrete output from the model. So this is very, very important. We don't have much time, but I will try to complete as much as possible. So it's like handing discrete outputs effectively using logits. So logits are essentially the last layer of the transformer model, where the weights are stored, and we can use those scores without even going into the generation phase. So this is the prompt, right? The passage is, cats are species of mammal whose origin are in ancient Egypt. The question is, tell me about cats. And my actual user prompt is, does the passage answer the query? So this is the passage and this is the query, and I'm asking whether the passage answers the query or not. Great, so let's me run. So here you see in the input IDs and this tokenizer, the prompt is passed and return tensors is set to true PT. And we are going to take the input IDs, is nothing but the tokens. And this 2 CUDA actually stores this 2 CUDA, which is if you have a GPU available. And output stores the model output. So model.generate, you give the tokenized input and it generates the output, and we can just decode it and get the output. You can see I have not cleaned it. So if I just clean the output, you can see the cleaned output will be there. So using the clean function, I'm not doing it right now. Now you see, this is the output that we are getting. So the output is yes. Correct. So the passage actually answers it, and we can see that here also. Now I will just change the prompt. Now my prompt is, the name of my cat is Luna. Tell me about cats. The question is same, the passage is changed. So does the passage answer the query? So this cat is a specific cat whose name is Luna. Right, let's see whether this gives output. So now you see this is able to give the correct output. It says no, that it doesn't answer what is cat. It says a particular type of cat or my cat whose name is Luna, but it doesn't specify what is cat. So you can see that you can utilize these smaller models for this kind of discrete task. But you can understand that the generative aspect of a model is very, very fluctuating. So you cannot control, even using some parameters, you cannot control what the output of the model will be. In that case, there is a very specific solution that we'll talk about. So given a query, tell me about cats, which of the following two passages is more relevant to the query? Now you see I make the thing more complex and output passage A or passage B. You can understand the enter prompt is complex right now from the previous ones, even from the one do goldfish grow. But the output here is very, very simple. So I'm asking whether passage A is better or passage B is better when compared to the query. So I've given the query, I've given passage A, I've given passage B. So it's much easier for this kind of models to give the output. So here you can understand the output should be passage B. Let's see what kind of output we get. And the model outputs passage B, and you can see how much fast it is because it's generating literally few tokens, right? Similarly, if I just reverse this, if I just interchange the passage A and passage B, let's see what kind of output we get. So it says passage A. So it's very consistent in this kind of aspect. But you can see there is a problem. The problem here is that if you generate hundreds of this kind of output, you will probably end up with like 50 or 60 of them being correct and some of them being hallucinated. Or maybe the output is not proper. In that case, we have to use something known as the logits. So we can directly extract the tokens that we want. So here, what is the output we want? We want either A or B, and we know that the model should be outputting A or B and nothing else. In that case, we can tokenize this using the same tokenizer as the model uses. You can see the token values. For A, basically the text A, the token value is 71. For B, the token value is 272. So what we are trying to do is, we are just going to skip a particular part of the model. Let me just show you here. So model takes your prompt. So model takes your prompt and it generates the output. It generates the output. So if you just expand this LLM, you will see that there are different stages in the transformer layer. So the very last layer of the transformer layer is where the logits are stored. Right? So these are the logits which are stored, which are then being used by a softmax function to actually generate the probabilities or calculate the probabilities, which we call as log probabilities, for the next word or generation of the next word. So if we entirely skip this, if we entirely skip this part, this generation process doesn't take place. So there is a possibility that we can directly take this logit and do the useful stuff. And you have to understand that what is the structure of a logit? It is nothing but a tensor. Tensor is a collection of vectors. So it has all the vocabulary. So for example, your model is trained on 30,000 different tokens or vocabularies. And for each of the token, it will give you a weight. So it is a matrix of weight and size. So this is the internal weight or parameter size of the model. So there is this vocabulary and this size. And for that, you will see that for a particular value, if the value is higher, you can identify for a particular instance what will be the output of the model. So this is just for a single token. For all the tokens, it is a stack of tokens. So if this is the logit for one token, there will be for another one, then there will be for another one. It's like that. And it keeps on generating the log probabilities for each of these layers of tokens. So what we are interested is in this first one. So the very first logit like token that we want. So So you see that using this tokenizer.encode, we are tokenizing this text because we want to identify for a particular token. So for example, if this is actually a token 1, token 2, and so on. So there is a token for A and there is a token for B. And we want to identify the values of logits for that particular columns. That is what we try to identify. We want to identify from the logit scores. So these are the two tokens. Now the tokenized prompt is nothing but we are just taking the same prompt and tokenizing it. Let's run it. And let's the model generate. Now you see I have changed some parameters. Do sample is set to false, top is set to none, return dictionary in generate set to true, and output score is equal to true, and max new tokens is 1. The max new tokens is 1 does mean that it was just generated the first logit sample. It won't generate anything else. And that's useful because we know the output will be either A or B. So in the first logit, it will be either A or B. And we can see what is the expected output of A and B, and we can then find out the actual output. Now the logit stack actually from this output, so torch.stack, so we can see that the output generates the score because we have said that output score is equals to true. This parameter returns the internal model weights, and we can take these weights and store it into the logic stack. Let's, okay, sorry, the torch is not initialized. Let's import it. Okay, so I haven't run it. So you'll see that the logit stack is now filled, and it took very, very less amount of time because it's just generating a single vector. And this tensor is nothing but, you can see, is a 3-dimensional tensor with only one value because it is having only logit of 1. And it is the value of all the tokens. So you can see the token 1, token 2, token 3, and so on. And which is the token that we want? Values for which token? The tokens I want is for 71 and 272. So if you go to this is a list. And if we just get the index of the item in 71 and 272, we can extract the logits of A and B. So here is what we are doing. So logit of A will be from the logit stack. I am just taking this index A item, and for logit B, I'm just taking index B item. Rest of them are 0 because it is a like 3-dimensional vector which is having only a single value in the end. And we are just going to print the logits. Now you have to understand, if the logit score is higher, the probability of predicting that particular value will be much higher. And this, since we are not using this generating function, it will not hallucinate in this case. So right now, once you have that, we have a very simple conditional function where we ask the model if logit A is greater than logit B or not. As simple as that. So if it's greater, then it's passage A. If it's not, then it's passage B. So let's print it. So it's giving passage A. Let's see what was the prompt. So this was the prompt. Yeah. So passage A is the output, as you can see. So in generation, we can get passage A. Without even generating, we can get passage A. And it is always advisable if you are using this discrete kind of output where you know the output will be, let's say, AB or ABCD, or maybe between 1 and 20, anything that is discrete and you know the output, it's generally recommended that you will be using this kind of SYN and this kind of objectives. Now, there is one thing that in GPT APIs, also you cannot use the logit score because they don't give you the logit weights. But for any other model that you will be working on, you will have this logit spread available to you for all the open source models. So let's just change it. Let's change the prompt to the previous one where the output is B. So this is the output is B. And you see the output, what it gets. So it says passage B is the output. It's quite consistent in this case. So let's run it once again. And now you will see that it says passage B even without generating. So this makes the end of this session. So I just want to know whether there are some questions available.